Hello guys, welcome back to Maths on African Motives, still on our mathematics for grade 10 level. So we are going to be focusing on the provincial examination of Gauteng province, which is June 2023 exam. So we are going to see this is paper one that we are going to have. So we're going to focus with our paper 1 hour, which is 50 marks in this case. So let us see what we are given. Remember that you are supposed to go through your instruction and information, make sure that you read everything. So here I asked you to present your answers according to the instructions of each question. You'll be given the instruction for the question that you'll be answering. So present your answer according to the instruction that you're given, and also clearly show all calculations, diagrams, graphs, etc. Which were used in determining the answer, and also answers only will not necessarily be awarded full marks. So please be careful, and also be careful on the degree of accuracy on rounding off your numbers to 2 decimal place unless stated otherwise in that question. Maybe they might give you to 1 decimal place, you use 1 decimal place, but any other questions, you use 2 decimal place as long they did not state anything. All right. Then the diagrams, they are not necessarily drawn to the scale, and number the questions correctly to the numbering system used in the question paper and write neatly and legibly. So you are supposed to have your work done properly, presented properly. All right. So let us see, guys, what we are given. Question number 1. Determine the following without the use of a calculator. The instruction there is without, and they even wrote this in bold so that you can properly see that they are saying you are not allowed to use a calculator. So we need the first question between, all right, so you're supposed to determine between which 2 consecutive integers lies the negative square root of 69, between which 2 consecutive integers. Consecutive means these 2 numbers, they are simply following each other in the order of maybe you're talking of rational integers, whatever that you're given, that you'll be talking about in that case. So in this case, we are talking about the integers. And remember, our integers, they are representing positive or negative whole numbers. All right, so these are positive or negative whole numbers. So for a number to be under the square root, we have got the negative square root of 69. Yes, you are told not to use a calculator, but you need a calculator to check, because like everything, you need to know like which number am I having that is closer to 69. All right, the numbers that we have, then we simply determine their square root, because we need the square root of a number. And like I said, we're going to just need our calculator to confirm what is the square root of 69. So when they are saying do not use a calculator, do not use a calculator once to simplify your answers, but you can test this to say the square root of 69, which is in this case, all right, just gonna put a negative so that we do not confuse each other here. So that's a negative 8,3 something. So we have a negative 8,3 something. This is what this number is representing. All right. So if this number is representing a negative 8, something, a negative 8,3 something, this is what you have in mind to say, all right, I have a number which is something like negative 8,3. What can be the boundaries? Because they're saying between which this number here, minus 8,3, is not an integer. It is because it is having a decimal. An integer, talk about positive or negative whole numbers. So we are saying the square root of negatives, the square root of 69 must lie between 2 numbers. It must be greater than a certain value, and it must be less than a certain value. So if we have got negative 8, what is the smallest, what can be the smallest integer that we can have, the closest value that we have to negative what? To negative 8, and is the smallest. The negative number that we can just get immediately after this negative 8 on this negative side is negative 9, because we're going to have negative 9, negative 10. Remember your number line, the numbers are increasing as they are going to the left side. So we've got negative 9, negative 10, negative 11, and so on. On the side of the right, they are now reducing as they go to the positive. So you're going to have negative 8 here. Remember, this is negative 8,3, meaning to say negative 8 is after that. All right, negative 8 is after. It's like 8 on your number line. This is 8,3. All right, this is 8, this is 9. So if we talk of the negative now, we're going to have it as a vice versa. So you're going to have negative 9 here, negative 8,3 here, negative 8 here. So meaning to say negative 8 is part of the integers that can be included on your simplification. Negative 7, negative 6, and so on. So on these numbers that we are going to have going this side and these numbers going this side, which one is the smallest here? We're going to take, the biggest one, which is negative 9, and here the smallest one, which is negative 8. So you're taking the ones that are on the boundaries, the ones that are on the boundaries, which is negative 9 and negative 8. These are the numbers at the boundaries. But here they are not given as direct numbers to say it's negative 8,3. You are given under the square root. So you have to ask yourself, in order to have a negative 9, it must be the square root of what? Which gives us a 9. It must be the square root of 81, which gives us a 9, and you multiply by a negative. So in actual sense, guys, to know the square root, you simply square that number. You're talking about 9. So simply square that number. 9 squared is what? It's 81. So it means we are limited at negative square root of 81 at this side, negative square root of 81, because the square root of 81, it gives us 9. Then you multiply by a negative, it's now negative 9. To get negative 8, you must have the square root of what? 64, which is simply 8 squared. So to know the square root, just to square that number. 8 squared is what? It's 64. So you must have the square root of 64 to get 8. But to get minus 8, you must have a negative there. So it must be negative square root of 64. Do not put a negative inside the square root. The square root of a negative number does not exist. If you put a negative under the square root like this, you are not going to have an answer. The square root of a negative number does not exist. So for this number to be a negative, the negative must be outside of the square root. You determine your square root, then whatever that you get, which is 8, you multiply it to the negative, it's now minus 8, which is this number that we want to see here. So these are the boundaries that you have. So like I said, in order for you to know this, you just limit yourself according to the boundary that you are given. And in this case, this number that we have, which was something like negative 8,3, it is going to lie in between these boundaries. From what? From the point of negative, from the number, which is negative 81, which is negative 9 to negative 8. These are the limits. These are the integers. Negative 9 is an integer. Negative 8 is an integer, because we said integers are positive or negative whole numbers. All right. So this is how the questions are given. Take a closer look. If you're given the square root of 5, this one is a positive number. But in order for me to know the consecutive numbers where this square root lies, I just have to test on my calculator what is the square root of 5, all right? I just have to test that before I determine the numbers. I just have to test the square root of 5 is equal to what? 2,21. So the number that I'm having here is approximately 2,2 something, which is not an integer, because you're talking of positive or negative. So the number that is at least less than 2 and being a perfect, because we must have it in a, because it's a square root. So which number do we have just before this 5? That is a perfect square, and because we must determine its square root. So if we just look at 5, the number smaller there is a 4, and the square root of 4 is a 2. So meaning to say we're going to focus with the square root of 4, which gives us a 2. The moment we move this side, there are numbers there, the square root of 6, the square root of 7, the square root of 8, the square root of 9, and so on. On these numbers, which one is the smallest one that is going to be simplified, and it gives you an integer of all these numbers. So you're going to see this one is not going to give us, because the square root of 6 is a decimal. So you test your value. Square root of 6 is a decimal. You move on, square root of 8, up to a condition where you reach the square root of 9. which gives you a whole number, which is 3. So you are going to be taken up to the square root of 9. So meaning to say, this square root of 5 that we have, it is going to lie between these two numbers. The square root of 5 is going to be greater than the square root of 4, which gave us 2, which is a whole number. And it must be less than the square root of 9, which gave us 3, which is a whole number. So you put the square root because the number you are given it under a square root. So you have to put it under a square root, all right? So if they give you direct the number that is not under a square root, you write the numbers as they are. Maybe you are given 2, 3, 5, 1, like that. And they are saying which of these is going to be bounded between which numbers, this number 2, So you know that, all right, 2, it's above 2. So meaning to say the whole number that is there must be a 2. And this is bounded at 3. That is the whole number that we have. Or we can test using this part of the square root. Then we square our number, 2 squared, 3 squared, which is 9. So it's the square root of 9. 2 squared, which is 4. So it's the square root of 4. So we have our square roots here. So guys, as we can see, it's something that is simply direct. You just have to play around with your questions, revise as much questions as you can, like I said before. All right, so that was our question, 2 marks for that. And we are given 1.2 that was showed that 0.9 is equal to 0, there's a bar there. All right, which means it's a recurring decimal. Remember, that type of a decimal is called a recurring decimal. All right, and we talked about this. Make sure that you watch also the introduction where we talked about this part of the recurring decimals. How are they converted to a rational term? All right, so we are given that 0.9 bar like this must be equal to 1, whereby 1 is a rational number. All right, 1 over 1. Remember, a rational number must be written in the form of A over B, where A is being an integer and B is being also an integer, but B cannot be equal to 0, all right? So as long as you can write your answer in this form, it means we are having it as a rational number. So we are simply having a condition where we are converting a recurring decimal. We are simply converting a recurring decimal in this case. That is what we are doing, to a rational number, in that case. All right, we are simply converting this to a rational number. So this 0.9 is a recurring decimal. All right, it's a recurring decimal. Let me put this. I think we're gonna need a lot of space, so let me just put it here. So from our introduction, remember what I said, guys. I said you are going to let the part that is recurring be equal to x. So you're gonna let x be equal to 0.9. So this, it's 0.99. This part is the one that is repeating. Then there is 999 and so on. So it's 0.9999. It's up to infinity, guys. So you can just even write 5 values, they are fine, or even 2 or 3 values, they are even fine. All right. So this 0.9, like this. What you're going to do is that you need to form an equation. All right. So to form an equation, the first thing is that you're going to multiply by 10, you multiply by 100, by 1,000, and so on until you have a condition where you can be able to subtract as long the digits after the comma, these values that are after the comma are the same between the two equations. You can be able to subtract your equations. So that means here I'm having this as my equation 1. All right. What I'm saying is that let us multiply by 10 and see what's going to happen. So you multiply x by 10. So if you multiply x by 10, that's going to be 10x, which is equal to 0.9 times 10. You simply move a comma, one digit to the right. So it's going to be 9, comma, these values after the comma. So it's going to be 9, comma. Remember, our comma is at this point. So it was supposed to be 9, comma. You take these values after the comma, which is 1, 2, 3, 4. So it's 1, 2, 3, 4. But remember, this part here and so on means there are so many values that are there after the comma. So you can take another 9 so that it can be the same values, like to say there are 5, yeah, they're also 5. So as you can see, these values after the comma are the same as these values after the comma. So I can use this equation and the equation 1 to subtract. If I want, I can multiply by 100. I find another equation. But as you can see, guys, what we want is to see that I have same digits, 9, 9, 9, 9, 9. I have got same digits, and these are the same digits that I'm seeing here. If it is 0, 0.57, 57, 57, and another one is given as a 5,57, 575, like this. It's not the same because here, all right, like if the comma is here, I'm going to be having 1, 2, 3, 4, 5, which is 1, 2, 3, 4, 5. All right, there's something that happened here. All right, I want you to see what I'm trying to say. It must be here. All right, the comma must be here. So it's going to be 7, 5, 7, 5, 7. These were the digits that we're supposed to have, which are 1, 2, 3, 4, 5. Here there were 1, 2, 3, 4, 5, 6. So as the order is, it is say 5, 7, 5, 7, and so on. So it means the digit that is supposed to have that we are supposed to have here is supposed to be a 5, because we are supposed to have the same digits. But if we check now these ones, they are not the same. This one, it's the digit after it's 5, yet the digit after it's 7. So it's 5, 7. This one is 7, 5. So they are not the same. So I cannot subtract, meaning to say I have to multiply again by 10 so that it will be 57, comma, because it will be here now. The comma is here. So it will be 57, comma, 5, 7, 5, 7, 5. So 1, 2, 3, 4, 5. I add another digit so that it becomes 6. 1, 2, 3, 4, 5, 6. So it must be a 7. So these digits after the comma, 5, 7, 5, 7 are the same as this one that we have, 5, 7, 5, 7. So that is the condition. So that's why I'm saying here, you can just work with these two equations, because already we can see that the digits after the comma are the same. So there's no need for us to even multiply by 100. It's enough what we have. All right, once you have this, what are you going to do? That the digits after the comma are the same. You are going to subtract your equations, all right? So you are going to subtract the given equations, all right? Subtract the given equations. So it can be equation 1 minus equation 2, or equation 2 minus equation 1. So since I've got bigger values on equation 2, it's going to be easier for me not to work with the negative, but work with positive. So I'm simply going to subtract. I'm going to write equation in short like this. So I'm going to subtract equation 2 minus equation 1, all right? So if I subtract equation 2 minus equation 1, it means I'm going to subtract these x together, all right? So it's going to be 10x minus x on equation 2 minus equation 1, all right? So 10x minus x, which is 1x. So it's going to be 10x minus x is equal to, I subtract the numbers together. So it's going to be from equation 2 to equation 1. So it's 9, 9, 9, 9, or many are they? 1, 2, 3, 4, 5. All right. This is this and so on here, guys. All right. So it's 9, 9, 9, 9, 1, 2, 3, 4, 5. All right. Minus here is the same as 0, 0.9999, like this, which are 5 of them. So you just take any values of your choice. Maybe you use the 2 values or 3 values, because here these values are repeating. It's different from that one where we have got 5, 7, 5, 7. There you need at least 4 values or 5 values after the comma, all right? But for this one, you can just use even 2 values, even 1 value, because as you can see, they are the same, all right? So if I subtract here, this is 1x. So I'm going to subtract 10 minus 1, which is 9x, is equal to, since the denominators here, the decimals are the same, this, when I subtract, these will cancel each other. These are same values, guys, as you can see. So they will cancel each other. So it's going to be 9 minus 0. And 9 minus 0 is going to give us a 9. So if I divide by 9 to obtain the value of x, it means, therefore, our x is going to be 9 divided by 9, which is a 1. So that is what we were being asked to show in that case. Show that this x, this 0.9 bar like this, a recurring decimal, is equal to 1. That was our question. So in order for us to show that, you are going to consider the part that you use on conversion from a recurring decimal to be written as a rational. as a rational number. So like I said, guys, I talked about this on the introduction part. Make sure that you watch all those videos on the introduction so that you understand what we are saying if we are answering these questions, right? So that we do not spend much time explaining like this. But anyways, it's good that we explain that we all understand if maybe you missed this part. All right, number 2.1, which is on question number 2, factorize the following expressions. I'm just going to use this part, guys. The following expression. All right, so these are, that's a quadrinomial because we've given 1, 2, 3, 4 terms. We're given 4 terms. So this one is best done by grouping. If you are given 4 terms, I said it is best done by grouping. So that is, we are given in this case 3x squared plus 9x minus 2xy minus 6y, like that. So if you have to consider by grouping, remember I said you have to consider that are there terms which are common between the first 2 terms and also between the last 2 terms. Do we have common terms? Yes, we do have. Between the first 2 terms, here x is common. Between the last 2 terms, y is common, and also consider the numbers and so on. So you can factor out the highest common factor between these 2 terms, which we're going to consider as 3 between the numbers 3 and 9. The highest common factor there is going to be a 3 and x. So we're going to consider, remember I said when we've got a common term, like when we've got a letter that is the same, you consider the one that has got the smallest exponent, which is 3x. So you're going to divide 3x squared divided by 3x. So that is like this, 3x squared over 3x. So the 3 and the 3 will cancel. X squared divided by 3 by x is going to be x. Here there are 2 of them. Here it's 1. Here there are 2. Here it's 1. So if we divide, we're going to remain with 1x on top. Or you can simply apply your laws of exponents, all right? This is, you are dividing same power, so you subtract your exponents, which is going to be x to the exponent of 1, which is same as what? Which is the same as x. So if we move on to the other term that you're given here, you are also going to divide 9x divided to the term that you factored out. What are you going to have at the end if you divide 9x to 3x? X and x are the same, they can cancel. So if we divide 9 by 3, we're going to have a 3. 3 into 3, that's 1. 3 into 9, that is a 3. 9 divided by 3, that is a 3. Okay, so you're going to obtain with a positive 3 in that case. All right, so that's a positive 3. Then we move on to the next 2 terms, which is the last 2 terms, this part. We are supposed to factor out, yes, whatever that is common, but you must have the same as in this bracket, which is x plus 3. So as we can see, the numbers inside this bracket or the terms that we have, they are positive. So we are supposed to factor out whatever that is going to make your terms to be positive. Since I have a negative and a negative, I have to factor it out so that I obtain positive terms. Remember, a negative when divided with a negative, it gives us a positive. All right, if we check between 2 and 6, 2 is the highest common factor, and also y is common, having same exponent. This is y to the exponent of 1, y to the exponent, so it's the same. So I'm going to factor out negative 2y in that case, so that I must obtain the same as what I have in this bracket and also being a positive. So let us divide and see. Minus 2xy divided to minus 2y, what are we going to have? Minus 2xy over minus 2y, like this. Negative and negative will cancel. 2 and 2 will cancel. Y and y will cancel. You remain with x. So that means here we are going to remain with x. The same thing on negative 6y there. If you are to divide by negative 2y, you're going to see that negative and negative will cancel. You get a positive. Y and y will cancel. You get a 1 there. Then 2 into 6, that's a positive 3. So meaning to say we are going to have our answer as a positive 3, which is actually very, very important to consider, like I said before, because you see that once the brackets are the same like this, that I have this bracket, which is common or the same as this bracket, I factor out that bracket. So I'm going to factor out the bracket of x plus 3. So just like the normal part that I had, if I factor out x plus 3, I have to divide back. So as you can see, the brackets are the same. So if you divide, you are going to remain here with what? With 3x. And if you divide here to x plus 3 here, we are going to remain this side with what? Minus 2y like this. All right, so this is what you were supposed to obtain at the end. Or even you can write it as 3x minus 2y into x plus 3. It's one and the same thing. It's representing one and the same answer. We are simply having the same answer in that case. All right, so let us check the other part, which is 2.3, simplify. So this one is not a factorization. It is to simplify back to your exponents on 2 point, all right, exponents 2.22. But the first part here is just your normal factorization. Remember, I said on the algebraic fractions that if you're working with a division, it is best for you to remove that before you talk of any factorization, before you do your factorization, whatever that you want, remove the division, because you might end up forgetting that you need to interchange your fractions or to remove this division. So do that in the first place. All right, so that means I'm going to introduce a multiplication in this case. So that will be m squared minus 64, everything over m squared plus 8m. So the moment I introduce a multiplication like this, what is going to happen is that you are going to interchange your second fraction, that you simply tip the second fraction. That means you're going to have m on top, and we are going to have m minus 8 in the denominator, that is the bottom part. So once you do this, you know that you are not going to worry about anything because already everything is under multiplication. And what I simply need here is to do my factorization properly. So I just have to factorize whatever that I'm having here properly. Having m squared minus 64, we can see that this is a difference of two squares being taken from our perfect squares, a squared minus b squared. If they are perfect squares, we are going to obtain the bracket of a minus b into the bracket of a plus b, where these are the square roots of the numbers that we have, or the terms that we have there. So the square root of m squared is m, the square root of 64 is 8. So you can test on your calculator. You'll see that the square root of 64 is going to give you an 8. That is to test that is truly a perfect square. So the square root of 64 is going to give us a whole number. So that means there we are having a perfect square. All right. So from this statement that we have here, that we are going to have a minus b, which is simply the square root. So we said the square root of m squared, which is m. All right. So we're going to just have two brackets in this case. All right. Another m here. Then one is going to subtract, another one is going to add. Okay. So we need the square root of 64. We simplify the square root of 64, we got 8. So this will be minus 8, this will be plus 8. So whether you start with m plus 8, you end up with m minus 8, it's just one and the same. M plus 8 into m minus 8 is just one and the same as what we have here. All right. Then on the second part, we are given a binomial in this case again, but this one is direct because it's not a continuum of a sum of two squares, because we do not have that part that we can factorize two squares when they are adding. We can only do that on subtraction. But here we just see that m is common. That is the only thing that we can notice there. So we can factor out the highest common factor, which is the one that has got the smallest exponent, which is m. So let us divide m squared divided to m, that will be m. All right, 8m divided to m, that will be 8. So you are simply canceling there. M and m will cancel, we remain with 8. All right, so this is going to be multiplied to m on the other side over m minus 8 from the introduction of the multiplication that we had, remember. So once you are at this stage with your factorization done, you can cancel your fractions as long you have common terms. It can be a bracket, it can be a single term, whatever that you have, and it must be between the numerator to the denominator. So do we have a condition whereby the numerator and the denominator are the same? And on that part, we can cancel. We have here m minus 8 and m minus 8, they will cancel, we get a 1. All right, m plus 8 and m plus 8, they can cancel, we get a 1. M and m here are the same, they can cancel, we get a 1. So meaning to say at the end, we are going to be left with a 1 because the whole part of the top which is the numerator, gives us a 1. 1 times 1 times 1, which is a 1 in that case, over 1 times 1 times 1, which is a 1, and this is going to give us a 1. So that is the idea of simplifying these questions. You just have to be very careful in your simplification, factorize your given expression properly, then cancel. But the first thing, like I said, do not forget, guys, to introduce your multiplication when there's a division. So it's very, very important that you do that in the first step, so that whatever that you are calculating, you know that already you are safe because you have already introduced your multiplication. All right, on 2.22, you are given to simplify again, this is 2 to the exponent of n minus 1. All right, so that's 2 to the exponent of n minus 1, which is being multiplied to 8 to the exponent of n plus 1, everything over 16 to the exponent of n. So in order for you to simplify, we can see that we've got 16, 8, and 2, which are very, very common in the base of 2. These numbers can be written in the simplest form in the base of 2, something that we are very, very much used about these numbers. So we can see that the 8 can be written as 2 to the exponent of 3. You can even test on your calculator to see which exponent can I use if I'm working with 2. So it's going to be 2. You try to the exponent of 2, you get a 4. You try 2 to the exponent of 3. As you can see, we get 8. So it means whenever we raise to the exponent of 3 on 2, we are going to have 8. So that's 2 to the exponent of 3 into whatever that we have on top there, which is n plus 1. We have another exponent already that we are given. The same thing on 16, you move on, you are still on 2. So if you move on 2 to the exponent of 4, you test. This gives you a 16. So meaning to say 16 can be written as 2 to the exponent of 4. But there's an exponent that we have, which is n. So we can simplify this. So what I'm simply trying to do here is that you see what is happening. Otherwise, this step, we could have not shown it. We could have just multiplied direct, but here it's for the sake so that you can properly see. So here it's going to be 2 to the exponent of n minus 1 times, you can multiply by 3, each and every part inside of the bracket. 3 times n, which is 3n, 3 times 1, which is going to give us a positive 3. All right. Then we move on to the denominator. You do the same thing. The exponent and exponent, they multiply each other. So it's going to be 4n. All right. So this will be 4n. So what it means is that we are back now to the condition where the powers that we are working with are the same. And what we just need is to work with the exponents. If it is like that, we've got 2, we've got 2. All right, we also have a 2 in the denominator. So we know that if we are multiplying, it's a to the exponent of m times a to the exponent of n. We are going to add the exponents together. So that means on top, we are going to add our exponents. But if we are dividing, we subtract. So it's either you're going to simplify the top part first, then you simplify to the denominator. So on the top, you are simply going to combine, guys. We are supposed to have something like this. 2 to the exponent of n minus 1 in this case. Then we add since we are multiplying. So it's going to be plus 3n plus 3 like this. So this is what we're supposed to have in actual sense. But if we add and collect our like terms, it's going to be 1n plus 3n, which is going to give us 4n. Then we move on, minus 1 plus 3, which is going to give us a plus 2. All right, so that's a plus 2 in this case. All right, everything over 2 to the exponent of 4n. Then we are back now to the division to say that this time we are dividing. So if we are dividing, what do? You subtract the exponents. In this case, that's a to the exponent of m minus n. So we are going to subtract this. So in actual sense, what does it mean in actual sense? In actual sense, it means we are supposed to have this as 2 to the exponent. Let us just subtract somewhere here. 2 to the exponent of 4n plus 2. This is what we have. All right. Then we subtract n. So we're going to subtract this part in the denominator, which is of 2 to the exponent of 4m. We subtract the exponent, which is 4n. Everything under 2, just like here under a, which is your base. So you're supposed to subtract 4m minus 4m on your like terms. It gives you a 0. So it means you are left with a 0 plus 2, which is a 2. So that is where we are obtaining 2 to the exponent of 2. And 2 to the exponent of 2 means 2 times 2, which is going to give us a 4. So that is how we are supposed to attempt this question, or this typical type of a question. You just have to expand in terms of the number that is. Sometimes you're given maybe an expansion which needs you to use two numbers. Maybe it's 2 and 3, or maybe it's 2 and 5. It can be like that. You have to work with the condition of the question. Here we can expand in the same number, which is 2, which is an advantage when it is like that, because it's a straightforward. You just have to apply your laws of exponents in order for you to simplify. So that was it, question 2, 9 marks. Then we move on to question 3. This one is something direct also. I'm gonna just try by all means to rush through and see how we're supposed to answer these questions here. So 3.1, we are given solve the for the unknown variable in each of the following. All right, so this is A into this part and so on and so on. So as you can see, guys, we can expand our brackets, then collect our like terms. So we're going to expand A and A. So that's 3.1. So A times A is going to give us A to the exponent of 3. Then A times 2A here, which will give you 2A to the exponent of 2. That's 1 plus 1, which is 2, all right? So make sure that you check the introduction on how to multiply your polynomials, all right? Then A and minus 3 is going to give us a minus 3A in that case, all right? So we're done. By multiplying by A, you move on to 1 in this case. 1 is going to multiply everything. 1 times A squared, which is going to give us A squared, which is A to the exponent of 2. 1 times 2A, which is going to give us a positive 2A in that case. Then 1 times a negative 3, which is going to give us a negative 3. So this must be equal to also what you have on the right-hand side. And on the right-hand side, you just have a single term, which is a monomial. In this case, we're going to multiply by A throughout the bracket. So that's A times A, just like here, A and A is going to give us A to the exponent of 3. Then A and 3A is going to give us 3A squared. Remember, A and A, we got A squared. So this is going to give us 3A squared. So we expanded the left-hand side, we expanded the right-hand side. So from there, we can simply collect our like terms on the on the left-hand side before we transpose anything. So we can collect our like terms, the ones that are having the same exponent. All right, so the exponent of 3, just gonna rewrite as it is, but we've got the exponent of 2 on A and the exponent of 2 here. So this is 2 plus 1A. If the number is not given, it means the coefficient there is a 1. So it's 2 plus 1 in this case, which is going to give us 3A squared. You do the same thing on the part of A. This is your A, this is your A. So you're gonna add the part of A, so that's negative 2 plus 2 in this case. So you can even use your calculator. You are going to get a negative 1, which is negative A. Negative 1A is same as negative A. You can choose not to write that negative 1. All right, then for the numbers, we only have negative 3. So this is just going to remain as it is. All right, so this must be equal to what we have on the right-hand side. And on the right-hand side, these terms cannot be added. They are not having the same exponent, so they cannot be added. So you're just going to rewrite as they are. But now, as you are to consider collecting of your like terms, you're going to see that if you collect your like terms, this to the other side is going to subtract here. So these two will cancel. All right. This one, you take it this side, it will cancel again. So in actual sense, we're supposed to take this, we subtract A cubed, we subtract 3A squared after transposing this to the left-hand side. These two are going to cancel. And also these two, they were going to cancel. So we're going to remain with this part alone, which is minus A minus 3 is equal to, remember, we have transposed this to the left-hand side. So there's nothing remaining here. So it's going to be a 0. So we can find the value of A, transpose the minus 3 to the other side, it becomes a negative. So that means minus a is equal to positive 3. So to find a, simply divide by -1. Here it means that there's a 1 which is there, so there's a -1. So we want to remove this so that we obtain a positive a. So 3 divided by -1, which is going to give us what? A negative 3 in that case. All right, so that was the value of a. Solve the equation. All right, so as you can see, guys, yeah, it was actually fine to stretch yourself further as you are revising. Then 3.2, another equation again, 2x squared plus x minus 3 is equal to 0. Remember, I talked also on our introduction about the quadratic equations by factorization. All right, so we are given this as 2x squared, that is 2x squared plus x minus 3 is equal to 0. So make sure that you also watch the introduction part. And I said on the factorization part of these guys, there are so many ways that you can do to perform your factorization. But I prefer this way, guys, that I'm going to solve this, but this side I'm going to factorize, all right? Yes, I'm solving for x, but I'm solving by what? By factorization. All right, by factorizing. So by factorizing, what does it mean? We are having 2x squared in this case. So what we are going to have is 2x squared plus x minus 3 is equal to 0. On a normal circumstance, if I'm given this, I said for that one, if you are used to that, it's fine. X squared plus 5x plus 6. You just have your two brackets. You're going to put x here, put an x, then factors of 6 that you add up to 5, which is 3 and 2. We are so much used to this, and we can quickly do that. But when the number is no longer a 1 in this case, and also you can't divide it to the other terms, because if you're going to have fractions, you are going to obtain the longer way of factorization. There are so many ways, like I said, where you need to determine the factors. But this one, if it is easier for you, then continue with it, whereby you multiply. So take note what I'm simply saying. You're going to multiply the first term. I explained also on the introduction of the factorization of this type. So make sure that you also watch for full understanding. But what I said is that you multiply the first and the last term, you get negative 6x squared. So it's 2 times negative 3, you get a negative 6x squared, first term to the last term. Then what you are going to do is you must determine, or you must find the factors, all right? You must find, in this case, factors of what? Of negative 6x squared, which add up to, which add up to the middle term, which is our middle term there, it's x. So which add up to positive x, all right? So the factors we are simply talking with, so we simply need two numbers in this case. There must be two numbers that you need there. So we need two numbers or two terms. Let's consider as terms because we have got x there. So let us just consider them as what? As two terms. So we need two terms. These two terms, if you multiply them, they must give you a negative 6. But the same terms, if you add them, they must add up to the middle term, which is x. I explained about this, guys, like I said. So in order for you to find these, you can have it as a trial and error. It's a trial, it's a trying stage. You try checking your values where which values gives you a negative 6. Let's consider 6 as a number. What are the factors of 6? The numbers that you multiply to get a 6, we can have 1 and 6, right? We can have 2 and 3. These numbers, they go back to 6. So in order for me to have a negative 6 now, that is the question. In order for me to have a negative 6, and it must be x squared, it means I'm going to put x later on, but I'm focusing on me having a negative 6 if I multiply. It means one of the numbers must be a negative to get a negative. Remember, negative times a positive, it gives us a negative answer. So to get a negative, one of the numbers must be a negative. So meaning to say, if I want, I can take this as a negative 1 and a positive 6. or I can change because I changed this to be a negative. So maybe I can choose 6 to be a negative. All right, like this. All right. Or the same on 2 and 3. These are the factors that we know that you multiply them to give you a 6, which is fine. But we want a condition where we get a negative 6. So we can try to have this as a negative 2, or we can try to have this as a negative 3. All right, because the moment we multiply this, we get negative 6. All these numbers, guys, if you multiply them, they give you a negative 6. All right, we're going to put the X letter on. All right, so it's like this, like there's X here, there's X here, there's X here, there's X here, there's X. That is what it means. So if you multiply X and X, you get what? X squared. But I'm worried about the numbers to say the numbers that you multiply to get negative. Which numbers are you talking about? All right. With the numbers that you got or the factors that you got, remember I said it's not about finding only the factors, but you must have only one part that you add to the middle term. So it must add up to X. So of these numbers that we have here, or of these terms, which part that when we add, if we add this, we get a positive X. If we add, we get a positive X. If we add, which part? So this is something that you can even do on your calculator by testing your values 1, 1. So it's the first one, it's 1 and negative 6. So if I add negative 6 to 1, what do I get? A negative 5, which is not X, because negative X means I'm talking about 1X, negative 1X. So you're going to try this and try, but if you move on to negative 2, that's where you're going to see that, okay, I get a 1, negative 2 and what? And 3. These ones, if I multiply them, they give us a negative 6, like I explained. But if I add these two numbers, I get a positive 1. Getting a positive 1, it means I have X, because 1X, like I said, is same as what? Is same as X. So these are the two numbers that I need. The ones that, remember, factors, they must be factors of negative 6x squared, and not only end there, they must add up to what we have in the middle term, which is 1x. So if we try this one, it's not going to give us 1x, because 2 plus minus 3, it is going to give us a -1, not a positive 1. We want a positive 1. So what's going to happen with those terms that add up to this and that? Since I say they add up to x, to this x, you are going to replace them on this x here. Why replacing on x? So that we are going to have 4 terms. We apply our factorization back of 4 terms, the one that we talked about by grouping. So what I'm simply saying is that we are going to substitute those 2 terms in place of x, because since they are adding up to x, so you substitute them where there is x. So you're going to substitute minus 2x plus 3x. This one, it's a plus. We take the number and its sign, all right? Minus 3 must be equal to 0. This is the negative 3 here. So as we can see, guys, the moment we have substituted those 2 terms where there is x, we have substituted those 2 terms. What is it that we have now? We are now having 1, 2, 3, 4 terms. So we can factorize that by grouping into 2. We are used to this. All right, so we can group this into 2 by divide by 2x. I mean, factor out 2x, which is the highest common factor here. So you're going to divide 2x squared, divide by 2x, which is x, minus 2x and 2, which is -1. Plus 3x and 3, we can factor out plus 3, we remain with x. If we divide 3x and 3, that's plus x. Minus 3 divided by plus 3, which is -1. This must be equal to 0. So what we simply have are the 2 brackets, which are the same in this case, which is the bracket of x minus 1. We factor it out. We remain here with 2x. Here we remain with what? With the plus 3. This must be equal to 0. So as you can see, this whole part that we see, it is going to be like this at the end, with this longer way that I explained before. But we shall talk, because like I said, like I promised, that I'm going to work with a different scenario. That one I need you to teach as a normal class. Then when we do questions, you'll be understanding it. But from this method, that is how we can factorize. And from there, you simply see that from the 0 concept, the product of A times B to be equal to 0, it means one of these must be equal to 0. It's either A must be equal to 0 or B must be equal to 0. So it's either this must be equal to 0, you find the x value. So if x minus 1 is equal to 0, we transpose minus 1 this side, it becomes a positive. So meaning to say x is going to be equal to 1, or if we do the same thing on this part, if we transpose, because we've got 2x plus 3, so if 2x plus 3 must be equal to 0, transpose 3 to that side, it becomes a negative 3, divide by 2 by 2. So that means your x was going to be negative 3 over 2. So this is your x, negative 3 over 2. So or x is going to be negative 3 over 2. So like I said, guys, there are so many ways that we can play around with this type of a question. What I just want you guys is to revise as much questions as you can so that you understand. And also the methods as we are revising, we shall be also talking of different methods as we are moving together. All right, on question 3.3, we are now asked to solve the inequality. All right, so that's an inequality. So for an inequality like this, guys, you simply solve direct. All right, so this is 3, which is less or equal to 2x minus 1 less than 7. So what you simply do is that you work with the middle term that we have. So on the middle term, what we need is to find x. So you're going to transpose this negative 1. Where are we transposing it? To the both sides. These are the sides of your inequality. So you're going to transpose negative 1 to this side. You transpose negative 1 to that side. What am I trying to say? If we take negative 1 to this side, it's going to be 3 plus 1, which is what? Which is a 4. So that means we are going to have 4, which is less than or equal to 2x, because we have taken this, that side. But taking this, it must be also taken to the other side, because these two, they are sharing the same point, which is minus 1, the same value. So minus 1 will be taken also to the other side here. So you add 1 here. What are you going to have? You are going to have 8 in that case. All right. So here you have an expression or an inequality for 2x. Not an inequality for x. We did not solve for x. You are supposed to solve for x. You are supposed to remain with x. So what are you going to do? You are going to divide these two. But just like what we did on negative 1, you transpose both sides. So the moment you divide by 2, you divide both sides. Here you divide by 2, here you divide by 2. Whatever that you do on the other side, you do it on the other side. That's how you solve this type of an inequality. So 4 divided by 2, that is 2 into 4, which is going to give us a 2. Is less or equal to 2, and 2, they cancel. You remain with x, which is less than 8 divided by 2 here, which is a 4. So that is going to be a 4. So as we can see here at this stage, that we now have our inequality in terms of x, not 2x or any other term. We must have x, a variable, which is x, and the coefficient there must be a 1, not a 3 or a 2. All right, so that was the idea, the 2 marks for that. Then 3.4, solve for x and y simultaneously. We've got 2 unknown values, x and y in that case. So as you can see, here we're just supposed to formulate the simultaneous equations. 3 to the exponent of x plus y is equal to 27 can be written in the base of 3. All right, we can write it in the base of 3. Remember, 27 is same as 3 to the exponent of 3. All right, but there is 27 to the exponent of 2. So it's going to be to the exponent of 2 also. All right, this is 27 to the exponent of 2. But 27 is 3 to the exponent of 3. Then there's an exponent of 2. Remember, an exponent and an exponent, they multiply each other. So it's going to be 3 to the exponent of 6. So this was going to be 3 to the exponent of 6 in that case. So as we can see that the bases here are the same. So it follows that the exponents are going to be the same. If we have a to the exponent of m equal to a to the exponent of n, it follows that m will be equal to n. As long the bases are the same, the exponents will be the same. So it means here it follows that, therefore, x plus y must be equal to 6, because this part here and this part here are the same. So you equate your exponents, x plus y and 6. So this must be equal to 6. So you have formulated an equation. You can even name it equation 1 in simply, you now have an equation in simplest form, which is your equation 1. You do the same thing on the other part where we are given 2 to the exponent of y, which is equal to, in this case, that is equal to 4 to the exponent of x plus 1. And we can write this 4 as a number in the base of 2, and that's 2 to the exponent of 2. But there is x plus 1 in that case. So what are we going to do is we can multiply whatever that you have. We've got 2 to the exponent of y, which is equal to, if you multiply by 2, that's 2 times x, which is 2 to the exponent of 2x, 2 times 1, which is a 2 in this case. The moment, guys, these two numbers are the same, the bases are the same, the moment we see that, we are going to equate our exponents. We can see there's a 2 here, there's a 2 here, they are the same. So you are going to equate your exponents, which is y and x plus 2. That is 2x plus 2. So that's another equation that you're going to formulate. Y is equal to, so let us just write it another way. Y is equal to, because we saw that this and this are the same. So y is going to be equal to 2x plus 2. So y is equal to 2x plus 2. All right, so this is going to be our second equation. All right, or I can just write equation 1, equation 2, like that, simply one and the same thing. All right. So since I'm having two equations that I'm used to, I can go back and use whatever method that I want. Is it elimination? Is it substitution? Whatever method that you are suitable with. But here I can take advantage of the substitution, because already I can see that on equation 2 here, y is already the subject. So if y is already the subject, I'm just going to substitute this in equation 1. So we are simply going to substitute, in this case, our equation 2, in this case, into equation 1. So what does it mean if we are substituting equation 2 into equation 1? It means in place of this y here, wherever we see this y there, we are going to substitute with 2x plus 2. So it means I'm going to have x plus, where there is y in equation 1, remember, in equation 1. So y is going to be substituted with 2x plus 2. So that's 2x plus 2 must be equal to 6. All right. So we have substituted for y there. The rest remains as it is, the 6, the x, whatever that you're given. So you can collect your like terms and so forth. So for x, because we are now just left with an equation that has got only x as the unknown. So we can collect our like terms. This is same as 1x, 1 plus 2, which is 3x. So this is going to give us 3x plus 2 is equal to 6. So to find the value of x, we can transpose 2 to the other side of the equation, which is going to give you a negative in that case. So that's 3x is going to be equal to 6 minus 2, which is a 4. So 6 minus 2, that's a 4. Then we can divide by 3. We can divide by what? By 3, both sides, to have the exact value of x. So this 3 and 3 cancels. You remain with 4 over 3. All right, so that is the first value that you're obtaining, which is the x value is 4 over 3. All right, but as you can see, in order for you to find the value of y, yes, you can come back here, equation 1, you substitute there, but it is easier to substitute in equation 2, because already in equation 2, this one, y is the subject, y is written in terms of x. And if y is written in terms of x, we can substitute because we have got the x value. So you can simply substitute there. So from equation 2, we have got y, which is equal to 2x plus 2. So y is going to be 2 into x. So it's easier to substitute there because already y is the subject. So that's our x, which is 4 over 3 plus 2 in that case. All right, so that is going to give us the value of y in this situation that we are having. All right, so let us simplify from our calculator and see that is 2 into, open a bracket, that's 4 over 3 like this, close the bracket to the exponent of, no, there's no exponent there, right? Just add 2 like this. So we are going to obtain the value of y in that case as 14 over 3. So that's the value of y is going to be 14 over 3. So these are the expected values that we're supposed to have, x being 4 over 3 and the value of y being 14 over 3. So you just have to revise, like I said, as much questions as you can. So that was our question 3, everything on question 3 having what, 11 marks. All right, so let us check the other part of our question paper and see how we're supposed to answer that part that you are given. So there we are back now to the functions, and that's a function as you can see here. All right, so there we've got question 4. The graphs of f of x is equal to 2x squared. Then we've got gx. All right, so this is the graph of f of x, which is f. Where are we having our f? All right, so this is our f of x, all right, which is the one that we are given as 2x squared. 2x squared minus 2. I'm just going to write so that I'll understand later on to use this. And gx, which is minus kx plus 1 over 1.5. And 1.5 is actually same as 3 over 2. So this can be given as negative k over x plus 3 over 2. All right, so that's same as 1.5 or 1,5 as a decimal. All right, so the question is, A and B are the x-intercepts of F and C. All right, A and B, these are the x-intercepts. All right. Then we are given that C is the y-intercept. All right, this C is the y-intercept. But this type of a graph, it happens at a point where it is along the line of symmetry, and it also becomes what we refer to as the turning point, which is the minimum value according to this graph that we are given. Of what? Of f of x, which is equal to 2x squared minus 2. So the first question there was simply direct. 4.1, write down 4.11, the domain of G in that case. What is it that we refer to when we are representing, or when we are talking about the domain? The domain, these are the x values. So the domain of G in this case, G is this function that we are having. Is it limited in terms of the x values? It does not have a limit. It's open wide in the x values. It can be simplified from any value up to any value, as long our x cannot be equal to what? As long our x cannot be equal to 0, that we have in the denominator there. Remember, the denominator cannot be equal to 0. So meaning to say x can be any number that we might think of, any real number that we can think of, but this x cannot be equal to 0 because of what? The fraction part. Remember, our denominator cannot be over 0. If you simplify on your calculator any number and divide it by 0, it gives you a math error. That is to show that part does not exist. All right, so that was our question. Then 4.12, the range of f. So the range, these are the y values limited or limiting f. So this is our f, this one. So as you can see, in order for you to have the range of f, you are limited at this point, at the turning point going up. All right, so that is where the y values are. As you are going up, there are no limits as you are going up, but as you go down, you'll be limited. You won't be able to exceed this point at C. And what does this point at C represents? That is the question. What does the point at C represents? This is our turning point, which is the y-intercept at a condition that we are given. C is the y-intercept, and we know that in the y-axis, x is equal to 0. In the x-axis, always y is equal to 0. So to find a value that is in the y-axis, you have to substitute x to be equal to 0 on f of x. We're talking about on f of x here. Remember, our f of x is given as 2x squared. So if I substitute as 0 there, I'm going to have the y value as a -2. So this point at C is -2. So if the point at C is -2, it means y is supposed to be bigger than -2 as we are going up. It's greater than -2. So y is supposed to be greater than or equal to -2. All right. Or how can we write the same range for f of x in short? Or how can we write another way? We can write this as the values taken from -2 up to where? Up to the positive infinity. They are not going to end as they go up to infinity. These values, that is the idea, because we are having endless values. The moment we say values are greater than or equal to -2, values that are greater than this, they do not end. So it's up to infinity. All right, so it's going to be taken from -2 up to positive infinity. All right, so that was the range of f. Then 4.13, the equation of the horizontal asymptote of G. All right, remember that the equation of the horizontal asymptote is given in the form, or you can have it 4.13. If it is a positive gradient, it is going to be given in the form of y is equal to x plus c, which is the point or the value that we obtain this c as at the point of intersection of your asymptotes in this case. All right. So here they are saying we must determine also, hey guys, I'm answering another question of line of symmetry. Here they want the horizontal asymptote of G. It's a direct question. I'm answering another question actually. Sorry for that. So this is our horizontal asymptote here, which is given from our equation of function, which is we are given here on our hyperbola. That is k over x plus 1.5, which is, I say, the same as 3 over 2. So this is the y value. So this line, it passes through the point 1,5, which is 1.5. So the line here is equal to y is equal to 1,5 or 1.5, which is 3 over 2. So meaning to say that is our horizontal asymptote. So y there is simply equal to 1,5, or you can write it as 1.5, or you can write it as 3 over 2, whatever that you want. All right, so that was the equation of what? The horizontal asymptote. Then for the vertical asymptote, we are going to take x. There's nothing added to x. So we take it along the y-axis at x is equal to 0. So x is equal to 0 is your vertical asymptote. So as you can see, these asymptotes, the equation of these, they meet at this point. That is the one that you use when you are calculating now for the equation of line of symmetry, which is the one that I wanted to answer there, which is not the one that they are asking here. Here they want horizontal asymptote full stop. All right, 4.2, calculate the length of AB. So AB, the length can be taken because here we are having a horizontal line in this case. So it's simply a distance between those 2 points. But what does these 2 points represent? The point A, the point A, B are the x-intercepts of f of x. These are the x-intercepts where we know that for the x-intercepts, y must be equal to 0. So we are supposed to find our x-intercepts first before we talk of the length, all right? So let us find our x-intercepts. So like I said, the x-intercepts are at a condition where y is equal to 0. So if y is equal to 0, it means this equation of our f of x, which is 2x squared minus, so we are given this as 2x squared minus 2, it must be equal to 0. Then we solve for x. So 2x squared transpose negative 2 to the other side, it becomes a positive 2 there. So you're going to have this as a positive 2. So to find x, you're going to divide by 2, which is a common term. So that means our x squared is going to be given as 2 divided by 2, which is a 1. So in order for you to find x, you're going to introduce the square root both sides. So remembering that the square root of any number is a plus or minus. So you're going to have plus or minus 1 in that case. So what does it mean? It means one of these values is a positive 1, one of the values is a negative 1. So at A, that is on the negative side, B on the positive side. So it means B is the one that is going to be positive. In this case, A is the one that is going to be negative. All right. So the distance between these guys, as you can see, we are moving one step to this point up to 0 because here we've got a 0. From A to this point, you have moved 1 unit. From 0 to B, you have moved 1 unit. So it's 1 unit plus 1 unit, which is 2 units. So it simply means the distance between the line AB is going to be given as 2 units. We can simply take that direct by sight. But if you want to do it by calculation, it follows that the distance of AB, you are going to have the difference between the maximum and the minimum value. The maximum value at B, which is 1, minus the minimum value at what? At negative 1. So it's always maximum minus the minimum value, which is negative 1. So it's going to be 1 minus 1, which is a plus. So 1 plus 1, that will be a 2. So that will be the distance of what? Of AB, which is 2 units in that case. All right. So, or you can even use distance formula applying your idea of if you are working with analytical geometry, there you can use those methods and so forth. But here you can take it direct. It's something that is direct. All right. On 4.3, show that k is equal to 9, and there we've got 2 marks to show that k is equal to 9. If we are to check on what we talk about or what we had on this function, this is what we have. All right, just gonna just erase 1 or 2 things here that are not that important. Like this part, I don't think is gonna be that important. All right, so let us see what we're supposed to have in this case. That is question 4.3. We want to show that k is equal to 9. All right, we want to show that k is equal to 9. So what you're going to need is you ask yourself, is there a complete point that I can substitute? Because that I can substitute into my equation, because here I'm having my gx. Remember, gx simply represents y is equal to, so you've got an equation there, y is equal to minus k over x plus 1.5, of which 1.5 we said is same as 3/2 or 1,5. So I'm just going to write as 3/2 there. So the question is, guys, be careful on this part. We have a point which lies on this function, which is our hyperbola. Do we have a function? Do we have a point which also lies on this hyperbola? There is a point D. Remember, we are told here that D, which is -2, 6, is a point of intersection between the two graphs, this one. So this point, it lies also on our hyperbola. So if it does that, it means we are going to substitute that point D, all right? So taking the point D, so taking the point D, which is given as -2, 6 in that case, all right? So our point D, that is -2, 6. Why taking the point? Because it gives us the x value and also the y value. So you simply have to substitute what you have, the x value and the y value. So the y value, which is y there, is what? It's 6, which is equal to minus k over x, the x value, which is -2 in that case, all right, plus 3/2. So as you can see here, guys, we've got a negative and a negative. So this will cancel. So that means we've got k/2, and we can even transpose the 3/2 to the other side so that it becomes a negative. So if we transpose this, guys, what are we going to have? All right. So let us transpose. We are going to have it as a negative. So it's 6 minus 3/2 like this, which is going to give us 9/2. So that means we are going to obtain 9/2, which is equal to, here we are left with k/2. All right, so this is k/2. So how can I determine the value of k? Is either I can cross multiply, or I can see that these numbers in the denominator are the same. So it simply means that k is equal to 9, or I can simply multiply by 2 to remove these numbers. So if I multiply by 2, it cancels, by 2, it cancels. So therefore, k is equal to 9. So as you can see here, k is equal to 9. Or like I said, you could have cross multiplied, which is one and the same thing. You could have cross multiplied at that stage, which is our final stage. 9/2 is equal to k/2. You can cross multiply 2 times 9, which is 18, is equal to 2 times k, which is 2k. So to find k, divide by 2 here, you divide by 2 here, it cancels. So that means our k is going to be 2 into 18, which is a 9. So as you can see, we are going to have the same thing, or the same answer on this one. We're going to have the same answer. So that was the value of k that satisfies this part. Right? So let us check what we have on the other part. What are they saying here? Write down the equation of the line of symmetry of G with a positive gradient. All right, so this is the question that I once mentioned before. So we want the one that has got a positive gradient. Remember, the line of symmetry of G, and is the line of symmetry of G in that case. All right, so remember, on the line of symmetry, what happens is that there are two lines that you can consider for the line of symmetry, but both of the lines that you're gonna consider, all right, both of these lines, they do pass through the point of intersection of the asymptotes. All right, remember, we obtain that our k is 9. Maybe you can just even write it here, 9, the 9 over this. All right, so what I'm saying here is that the two equations of the line of symmetry, they pass through the point of intersection of the asymptotes. Remember, we said the asymptotes, we've got them at y is equal to 1,5, and also this one in the y-axis at x is equal to 0. So what we refer as the line of symmetry for this graph of G, which is your hyperbola in this case, it is going to pass through the asymptote, the point of intersection of the asymptote, that it is going to pass through the point of 0,5 with a positive gradient, and this one with a negative gradient is going to pass that way. So these are the two lines that we expect to have. All right, these are the two lines that we expect to have. The one that has got a positive gradient going this way, but all passing through the point of intersection of the asymptotes. What am I trying to say when I'm saying point of intersection of the asymptotes? Where the asymptotes meet, they meet at point where x there is 0 and y is 0,5. So it means we are having a point where x is 0 and y is being 0,5. Remember that the equation of the asymptote, the equation of the line of symmetry for the one that has got a positive gradient is given as, so that's 4.4. The equation is given as y is equal to x plus c. It always having a positive one. For the one with a negative gradient, it's going to be negative x plus, always having negative one. That number is not going to change into a 2 or into a 3. It's always a positive one here. So what you need is to find the value of c. That's where the point now plays a role of the asymptotes. At the asymptote, x is equal to 0. At the asymptote, y is equal to 0. The equation there, y is equal to 1,5. So we can substitute the value of y being 1,5 is equal to the x value being as 0. So that's 0 plus c, meaning to say 1,5 is equal to c. So if c is 1,5, it means therefore our equation is supposed to be y is equal to x plus c, which is our c is 1,5. So that was supposed to be our final solution or our final answer for the equation of the asymptote, the equation of the line of symmetry that has got a positive gradient. So like I said, if they wanted you to find the one that has got a negative gradient, all right, the one that has got a negative gradient for the line of symmetry, your answer was going to be y is equal to minus x plus c. The only difference is that positive gradient, this is positive. Negative gradient, this is negative. And always, this is -1. Always, this is a positive one. So as you can see, you also have to find the c there. At the same point, you use the same point, the same point of intersection of your asymptotes where x is 0 and y is 1,5. So y, 1,5, then x being a 0 plus c. So as you can see, c is going to be 1,5. So our equation is going to be y is equal to minus x plus 1,5. So since we see that 1,5, guys, let me conclude this way. Since we see that at the graph here, on our graph here, since we can see that 1,5 is on the y-axis, it is the value of y because we're referring when x is also equal to 0, y is there, that is being our y-intercept. And c, it represents the y-intercept. So if you have the y-intercept direct, there is no need for you to even substitute. You can even directly substitute because you know your equation has got a positive gradient. That is what you know. So you know that your equation was supposed to be in the form of y is equal to x plus c, whereby c is the y-intercept. And I have the y-intercept where of the asymptote, meaning the y value, because the moment when x is equal to 0, that point, it passes through the y-axis at 1,5. So you're just going to add a 1,5 on your answer. This is what you could have just taken direct. But for the sake of revision, it's very, very important that you understand this also as well. It's very, very important for you to understand that. All right, this question has a lot of things to consider. How many marks? 17 marks. All right, that's why. Let's see. Write down the values of x such that gx is greater than f of x, and that is 1 mark. So gx is supposed to be greater than f of x. So you just need a condition where gx is above f of x. This gx is supposed to be on top, all right, above, or simply means on top of what? Of f of x, that is to be greater than. We must find gx on top, all right? So that's 5.51. So where do we have on our graph here a condition where gx is on top of our f of x? Okay, let us just write. Let us just be clear here and be together as we move on. We just need to be together, guys. Whereas I didn't know that this is going to take time, this question paper. Anyways, let's see. So where are we going to have a condition where our graph, because gx is the one that you are considering, right? You are considering to say gx is supposed to be greater than f of x. Gx is supposed to be greater than f of x. So if we consider that, we are going to see that we need a condition where gx is above, it's on top. This is your gx, your hyperbola in that case. So if we check from the beginning on the left side here, from this side, gx is this one. It's below f of x because f of x is the one on top. So it's below up to this point at D, where x at point D, our x value, remember D is minus 6.2. So the x value there is -2. Sorry, that's a -2. So from -2, as it goes, G is now on top. Well, this is your G. G is the one that is above. It's now positive. As F is below up to the y-axis. But G is not considered at the y-axis. It cannot reach the y-axis. But we know that in the y-axis, x is equal to 0. So these are the boundaries where G is positive. G is on top, it's positive. So it's bounded between -2 and a 0. So it means the moment we see our x values, they must be greater than, because we do not have equal to there. So it must be greater than, all right, the -2 that we have on this side. The same x, it must be less than a 0. For 0, it cannot reach 0 because 0 is what? A asymptote. Or we can have this as x can be taken from -2 to 0 like this in short, all right? Let's check again from 0, because here we can see up to 0, we saw that our G was on top. We want a condition where G is what? Is on top. All right, the moment we move to 0 here, the moment we move from 0, 1, we can see that this time it's F which is on top, not G. G is down, G is this one below. So this one cannot work this side. There's nothing that we can get because G is below, but we need a condition where G is supposed to be on top of F. So that was going to be the only solution, or the only part where our Gx is greater than what? Is greater than f of x. All right, both f and g increase as x is increasing. We want a condition where the two graphs are increasing. To increase, that is, they are going up. That is to increase, our graphs are going up as x is increasing. X is increasing as we are moving this side to the right side. -3, -2, the x values, they'll be increasing. 0, 1, 2, 3, and so on and so on. But as we consider what is happening between the regions here at -2, the y values, they are decreasing for f. As you can see, they are going down. Yes, for g, they are going up. All right, they are decreasing up to 0 there. All right. The moment we move on to 0 here, if you check the y values, they are going up. They are now going up. This one from infinity, from this infinity, whatever that we have, they are still going up. So we can take of values that are from 0 to the y of f, it's from 0. But 0 cannot be considered on G. G cannot be at 0 because at 0, that's an asymptote. So we need values that are greater than 0 for this one to have both functions increasing. We need values that are greater than what? That are greater than 0. So our x is supposed to be greater than 0. But how do you write values that are greater than 0? You can simply say the x values are taken from 0 to infinity. They do not end. As long as they start from 0 going to the positive, they will end up to, they won't even end. All right. So that was the condition that you are given there. All right, then 4.6, determine the transformation of G to H. All right, the transformation of G to H. Let's see our G first. Our G, remember, it was given as what? This is our Gx, which is minus kx, minus k over x, and we got our k as 9. So it's going to be minus 9 over x plus 3 over 2, which I said it can be 1.5 or minus, or mean plus 3 over 2. So 3 over, not 3 over 2, but 1,5, not 3 over 2. This is a 1,5, this one. 3 over 2 as a decimal is 1,5, right? That's a positive 1,5. So meaning to say our normal function of G in that case, all right? Our normal function of G, the one that we are given before there on top, it was given as negative 9 over x plus 3 over 2, but I'm just going to write as a decimal since this one is given as a decimal. So as a decimal, we said it's going to be 1,5. All right, 1.5 is same as 1,5 guys, or is same as 3 over 2 as an improper fraction, but we want as a decimal. So this is our Gx. Now it is being transformed to Hx, which is our Hx is given as, now it's a positive there, as you can see, it's now positive 9x, and this number is now negative 3,5, not just 1,5, but 3,5. The number is also changed. So it's now negative 3,5. All right. If the values of x are being affected in this case that we see that it was a negative 9 over x, the moment we multiply that by a negative, like Gx, let us just say Gx is minus f of x, or maybe Hx is equal to minus f of x. It's a reflection that is happening, that one. So that it represents a reflection in the y-axis, all right? So meaning to say, to have or to change from a negative 9 to a positive 9, that one is a reflection. So you're going to have a reflection. The first transformation is a reflection in the y-axis. So you're going to take this in the y-axis. But because of the type of graph that we are talking about, remember, this is the graph that we are talking about here, where we have got two shapes like this. So we can even have it in the y or even in the x, all right? Depending with what you want. But according to the y-axis, this is what you're going to have. Then what about the numbers? These, remember here we talked about the asymptotes before. So the asymptote was at 1,5. Now it's at minus 3,5. The asymptote, if you take note about what we talked about before, it represents the y values. These are the values of y. If you talk about, if you are representing this asymptote, these are the y values. So the y values was what at 1,5. But on the transformed graph, we now see the asymptote of y at negative 4,5. That is what happened. That is what we see. It was negative 3,5, sorry, negative 3,5. So what happened? The points, they simply shifted. From this point, it simply shifted going down. How many units going down from 1,5 up to minus 3,5? How many units do we have? So we can subtract 1,5 minus 3,5 like that. We know the difference, which is going to be 5 in that case. So it's going to be 5 units. So it means from 1,5 to minus 3,5, this point, this line, the asymptote, it has to go down 5 units. It is going down 5 units, all right? So that is a transformation of a translation that is happening. So this part here, that's a translation, all right? So another transformation there was a translation, which is a shift of what? Which is a shift of, we said 5 units, all right? A shift of 5 units downwards, going down, all right? All right, that is the idea. I think all the transformation are there, 2 marks for that, all right? So you named the first one reflection and the other one a shift, which is a translation. So this one is a translation, not a reflection. This one is a translation. There's a difference, great difference between a translation and a reflection. they are not the same, and they are not even, they cannot even be considered to be the same in our simplification. All right, so do not even consider these two functions to be the same in your simplification. All right. Then on the other part, which is our question number 5, we are given hx. Hx is equal to 2 to the exponent of x minus 1, 5.1. Calculate the x-intercept. So remember, guys, the x-intercept is on a condition where y is equal to 0. So if y is equal to 0, it means we are going to have 0 is equal to 2 to the exponent of x minus 4. So remember, we want to calculate x, so you can transpose minus 4 to this side so that it can be a positive. So 4 is equal to 2 to the exponent of x. We are back to our exponents. Actually, this is an exponential equation that we have. So we are going to make the bases to be the same so that we equate the exponents. So 4 in the base of 2, remember that's 2 to the exponent of 2, equal to 2 to the exponent of x. So since the bases here are the same, what you're going to do is to equate your exponents where x is equal to 2 in that case. All right, so that means our x-intercept was at 2, so x is equal to 2, or you can write as 2, 0. All right, then so like I said, you can write this as 2, 0. Then the y-intercept, remember, it's any condition where x is equal to 0. So this one you can simply substitute. Sorry for that. This one you can simply substitute because you're given y is equal to 2 to the exponent of x, and we said x is 0. And the y-intercept. So you can just substitute this even on your calculator, just simplify, direct. You have your y value, that's 2 to the exponent of 0, which is 1. All right, whatever that you have there from 2 to the exponent of 0, you subtract 4. So that is going to give us a -3. So that's y is equal to a -3. So the y-intercept is at -3, or you can just write it as a point 0 minus 3. All right, then we move on to the other part of the graph. With this information, they are saying hence sketch. All right, so this is not part of the graph, but this is how your graph was supposed to be. You're supposed to sketch our graph like this. All right, so they are saying sketch this graph and so on. So as you can see, guys, we've got the x-intercept at 2, all right, where y is equal to 0, x is equal to 2. So this is the most important point. You were going to mark x-intercept at 2, right? This is your x-axis. This is your y-axis, all right? You move on to the y-intercept, which was at -3. You mark at -3 your point, all right? So meaning to say, as we know that if we are dealing with an exponential function, we are going to check also the number that is being added or subtracted here. The number that is indicated, the y value there, is your asymptote, all right? So that one is your asymptote in that case. So what does it mean? It means the graph cannot reach -4. It is going to be limited to -4. So we're going to represent this with a broken line. The line of y is equal to -4, which is our asymptote in that case. All right, so this one is our asymptote in that manner. All right, so that was what you're supposed to have for this sketch. You can have 4 marks if you do this. All right, then the other part, write down the point of intersection between this graph of 2 to the exponent of x minus 1, which is one that we sketched, and the one of, so if we check here, 1/2x, they just play around with us. Go back to the exponents, guys. We know that 1/, represents to a negative exponent. So this is 2 to the exponent of -x minus 4, like that. All right. So what does it mean? It means we still have the same asymptote at -4. The only part that changed is having a negative. So it's an inverse that is happening. Remember, if the x values are being multiplied direct, like we are given y is equal to f of x, then on another part, you multiply it direct, y is equal to f of minus x, like that. Or maybe it's another part, this was hx, this is, you are now multiplying by a negative like this. That one, it is going to affect our values. All right, you are going to reflect everything, and you reflect it in the y-axis. In the x-axis, it must be a condition of y is equal to minus f of x, like this. You reflect, it means a reflection in the x-axis. But when x is affected like this, it opposes y. is it's a reflection there of what in the y-axis. So what we simply needed here was to reflect this graph in the y-axis. You're going to see these points here, they will be seen on this side. These points will be seen on the other side. That is a reflection in the x-axis. So this part is just going to be at -3 somewhere there. It's just going to be a repetition, guys. It's just going to be a repetition, but having a reflection on this side. All right, just something like this, passing through to like this, something like this up to -3. Then it goes like something like that. All right, so it's going to be something of that nature. So like I said, it is just going to be trying to approach this part. So at the point of intersection, you can see it can only happen that these two graphs, they intersect at what? At and the y-axis, that is at what? At -3, that is at 0, -3 in that case. That is our point of intersection. You are not solving anything in this case. You are not solving anything like what we do on other questions, where you have to find the point of intersection. You have to solve your equations. On this one, you were not solving anything. You just needed the idea to know the relationship between these two. Yes, you can solve your equations, which is fine. Remember, I explained about the issue of point of intersection to say at the point of intersection, the two graphs are equal. So it means you can solve to say these two are equal. So 2 to the exponent of x minus 4 must be equal to 1 over 2 to the exponent of x minus 4 like this. So I can transpose either to other side, but the moment I transpose, as you can see, guys, here, even if I transpose this 2 to the exponent of x minus 1 over 2 to the exponent, the moment I transpose this side, it's going to be a +4, which is a 0. So definitely here, whatever that I'm going to simplify for x, it is going to be at what? At 0. So to find the y value, you can now substitute in any of the equations. Substitute 0 there, y becomes what? A -3, because if you substitute as 0 here, it's going to be 2 to the exponent of 0 minus 4. That is 1 minus 4, which is -3. So that means we are back again to the same point of 0 minus 3. That is it, guys. 50 marks for everything that we did in this class. And I didn't expect that it's going to be this big, but as you can see, guys, that is what we're supposed to do. So here I explained in a way that you're supposed to understand not just this question paper, but every topic. As you revise even another question paper with the knowledge that you have, you can use it. It's not about answering just a single question paper, but to know, even if you are alone answering another question paper, you have the idea or information deep enough to that you can use it to answer any question that you might be given in a future case.